Hey everyone, this is Nico Earnshaw, and today we are unveiling the brand new Decentraland Crypto Utils library. So this library is meant to be a huge lifesaver when it comes to doing anything that has to do with the blockchain in a Decentraland scene. So all of these things are really like helper libraries. Everything that this library makes possible really is already possible with the current state of the SDK. However, I'll be the first to admit that the current tools we have for doing that are quite a challenge, especially probably if you come from a game developer background. If you look into our documentation page, the scene blockchain operations page, you'll see that, a lot of things are possible, but they take quite a lot to wrap your head around. And yeah, we definitely needed a way to make these things easier. And so this library exposes a lot of the common functions that you might want to do and makes some one-liner functions that are so much more accessible. So first of all, I want to mention that this library is probably not 100% polished. In fact, we've been up until just a couple of hours ago still troubleshooting things, and the documentation is still not finished. However, we felt that it was quite important to make this available to you guys as soon as possible, because it's already usable, at least for several of the things that it's possible to do. And so yeah, it was worth sharing already. The other disclaimer I wanted to make is that I am by no means a blockchain expert. In fact, I could still consider myself to be kind of a newbie with all things blockchain. I've never coded a single line in Solidity. So the real mastermind behind all of this is H. Privakos, also known as Gillian. You might know him. He is a real whiz when it comes to hacking stuff and doing stuff with the blockchain. And I was just here to document and troubleshoot and build examples with it. So yeah, I probably won't be able to answer the most complicated questions that you guys can throw at me. But the whole purpose of this is to make this accessible mainly to people who are not terribly experienced when it comes to developing with the blockchain. In fact, we have functions that are specially dedicated to using Mana, for example, or specially dedicated to using our marketplace, so that these things that are central to the Decentraland becomes a lot more accessible. So if you want to use this library, you can check out the awesome repository and go to the library section. And there you find a link to all of this, and the documentation is all here in the README page of the repository. There are also several examples that we built that use this library, and they're also here available in the awesome repository. If you check out these, the crypto library section, you find that all of these use this library in one way or another. These examples here also include these 3D models that we specially built. One for a donation box, another for a button that is paid, another for a paid lever. So these, you can actually argue that the button and the lever scene are essentially the same with a different skin, and they kind of are, but the whole purpose of this is also for you guys to be able to use these models whenever you want, since we think that it's also a great usability practice for players to get used to seeing the same shapes of buttons when it comes to paid buttons, because of course they will expect the payment and won't be taken by surprise when they're asked to pay for something. So the first thing we'll do in this little tutorial is we will dig deep into this scene, the paid button one. For the purposes of this, I have built a stripped down version of the same scene that doesn't include any of the part that uses this library. So the first thing we need to do is install the library in the scene. To do that, we're just gonna do npm I @decentraland/cryptoutils, as you can find in the README, and I can just install that into the folder where I have this project, and with that all of the functions in the library will be available to use. And then we can import these functions, these folders from the library into our scene. So let's first of all give you a bit of an overview of what the scene is like. It's pretty straightforward. There's something that I built with a builder, and then there's a door and a button. And yeah, just give it a second to load. And as I mentioned, right now the scene is not using the crypto library, so if you click on the button, this will open this little UI, and if I accept this these conditions to pay 10 mana, the door will open, just straight, and also the button will animate when that happens. So if I look at the code for the scene, it's all fairly like compartmentalized. So there's this little function that calls all of the builder static stuff, then the door is its own enclosed little object that I'm calling, and also the button it's a class that I've defined specifically for the scene, and the class takes a couple of arguments that include what wallet to send money to and the amount of money to send. So if I look at this file here, we got the definition for the paid button class, which takes all of these arguments, and yeah, it just shows the the GLTF shape for the button and the animation, and then we go into this horrible part that has all of the code for the UI that you just saw. If I were to eat my own dog food and use my UI library that I unveiled a couple of days ago, you would see that all of this chunk of code would be maybe like 4 or 5 lines of code. I should totally change that. I haven't had time to do it. But yeah, for now, just ignore all of this chunk. What really matters here, what we're going to work with now, is this pay fee section here. So right now, when we call the pay fee function, we're not really paying the fee, we're just going straight to the consequence of paying, which is that one, the door opens, and then you hear the sound for the click, and the button also plays its own animation. What we want to do is we want to prevent this from happening until we have paid a fee. So first of all, we are gonna import the mana section of our crypto library. So we're gonna just add one line at the top of this file, importing this. So now that mana is available, we can do mana.send, and the send function really just requires 2 arguments. One is the address that we want to send the mana to, and the other is the amount of mana in normal numbers. No, we don't need to think in terms of way, which if you're familiar with that, you know that it's very error prone and counterintuitive. So what we will do now is yeah, since this paid button class already is taking in an address and an amount to be paid, instead of directly writing down a wallet here, I'm gonna do this dot what was it, address, and this dot payment amount. Of course, if I wasn't working inside this object, I would just straight up write the number 10 here, and I would write the string for the address that I want to send stuff to. And yeah, of course, we don't want to do any of this until this function has been completed. So what we'll do is do then, so that we can execute some code only after the function has finished. And we will get all of this chunk of code and stick it in here. So now when we run our scene, we should see it behave differently. But before we do, let's add a bit of suspense to this. It's important to note that right here I am using the Ropsten network. If you're familiar with everything to do with blockchain development, this will sound all fairly obvious and basic, but bear with me. Usually you're always using the mainnet. The mainnet is, let's say, the real blockchain. It's where things have a true value and where you want to actually do stuff. But then there are several test networks that are there just for the purpose of allowing you to test stuff in a safe environment where there are no consequences that will cost you money if you commit any kind of mistake. So I would argue the most popular one of these is a Ropsten network, and that's what we're using right now. Now, if I am using the Ropsten network, there is one thing I need to take into account, is that I need to have Mana and Ether inside Ropsten. It's not the same to have Mana and Ether in mainnet. These are like separate networks, and the tokens that exist there are a whole other story. So, for some reason the scene wasn't loading there. I don't know why. If I don't have Ropsten Mana or Ropsten Ether, you can find here in this documentation page right at the very end that we shared a couple of links for the Ether faucet and a Ropsten faucet. So for example, if I go to an Ether faucet, all I have to do is paste my my Ethereum wallet here and send me this Ether. Oh, sorry, I had just used this a few minutes ago, and it had worked beautifully, but since I just did it, it's apparently not letting me again for a period of time. But if I hadn't done that just a few minutes ago, I would have now gotten just free money out of the blue. So that's a wonderful thing about Ropsten network. Everything is free. Also, that's the the bad thing. Everything is free, so nothing is valuable. Same goes for this. If I go to the Mana faucet, all I have to do is provide my Ethereum address and click refill, and I get a new refill of Mana into my wallet. As I had just done this a few minutes ago while testing this, I can't do it right now. But be assured that if you were doing it yourself, you could just click and get free money. Okay. So, having done that, I am now ready to try my scene in Ropsten and not worry about, having to pay an actual fee for everything I do. One more thing I need to take care of. Whenever I run a preview of a scene that requires the blockchain anyway, I need to add this parameter to the URL manually and enable web_web3. Why do I need to do this? This is for MetaMask to be connected to the scene. Otherwise, I won't be able to use any of the features that have to do with the blockchain. And I know this is not great usability for developing this, but it's something that we need to fix eventually. By the way, be assured that players, when they enter your scene, they don't need to add this. This is only necessary when you're running a preview of the scene. So now, because I added this, I'm being asked to sign this. And now, when I click my button and I approve this, the door doesn't open. Instead, MetaMask is going to ask me to do a transaction. Awesome. So if I confirm this transaction, voila, the door opens. So this is great, but this is also abusable. So if I were to I can edit my own gas fees whenever I do a transaction, and if I wanted, I could set the gas fee to be 0 or to be way below the market value. And if I were to do that, the transaction would never complete. However, the door would still open because the door just opens whenever I accept the transaction, not when the transaction is completed. However, we have a workaround for that included into this library, which, see, the transaction just now completed. However, the door was already open. So the send function has a third argument, which is wait confirm. And if I set that argument to true, what's going to happen now is that this then statement is not going to be called until the transaction is actually mined and added to one of the blocks in the blockchain. So through that, we can absolutely avoid that exploit. Now, the downside, as you'll see now, is that when doing that, I'm going to have to wait. I'm going to have to wait for the transaction to be finished, and depending on how much of a gas fee I'm willing to pay, that wait could even be a couple of minutes. So now, as you can see, I just confirmed the transaction, but the door is not going to open, not until the transaction has... There we go. Well, that was quite fast because I'm in Ropsten. If I were in mainnet, it would surely take a bit longer. But see, there's an interesting trade-off. So if, for example, you were doing a scene like, where is the, here. So you were doing like the donation box scene, you probably wouldn't want to wait for that. Like this donation box has a little animation of a heart that pops up whenever you donate. You probably want to assume people's goodwill because there is no real incentive to, abuse this. So you probably would want to, trigger that animation straight up when people confirm the transaction and not wait for the transaction to be minted. However, if you really have something important to unveil behind that door, you probably do want to wait for that to be minted. Yeah, because otherwise people might be abusing it. Okay, awesome. We will not go into these other examples because they're fairly straightforward. They're just variations on the same kind of thing. Now, a thing that we need to consider is that, as we all have been aware of, like in the past couple of months, the prices in Ethereum for gas are pretty elevated, and there are efforts to use a second layer net to be able to have these transaction prices a lot lower and to make the transactions occur a lot faster. We will soon be unveiling some solutions for that. However, of course, there is always a trade-off, because although the experience of using a second layer blockchain is definitely, more economical and, better overall, the usability of accessing the second layer is still a challenge. So depending on what you want to do and what kind of audience you want to build for, you might still want to consider this trade-off and maybe not use a second net, depending on how many transactions you want to actually run, etc. This talk is, however, like that topic is a bit out of scope for what I want to talk about today, so we'll leave that for another occasion. So what else can we do? Let's take this same scene and just for fun, let's add the UI library that we were discussing a couple of days back. And of course we don't really need this for our scene, but I think that it's gonna make the demonstrations a bit more fun. So just gonna import the UI library here. I just installed the UI library as an npm package. And now, for example, let's say that this, of course, is like, and now I'm just breaking the scene, right? But I'm gonna show stuff when I do this. Right now, instead of opening the door, let's just check the player's balance. We can do mana.mybalance and just print whatever the player is, how much mana the player is currently holding. So we can do balance equals await. Oh, of course, we need to make this function sync, and that is an interesting point here. All of the functions, or pretty much, I'd say all of the functions exposed by this library will always need to be run in an async way. That is because you're always waiting for the blockchain to return something, and as that is, of course, not part of the main thread that you're executing in your scene, it's always necessary to, have a second thread, like here, for example, for stuff to happen in a separate thread and keep running in your scene while you're waiting for this response. So right here, I was adding an await before receiving the result from this function. So now I can do UI dot display announcement balance and just print out the balance. Yeah, balance is a number and I need to send it as a string. So if I just do that, you'll see that through the UI library I can, gotta run this again. Through the UI library, I'm gonna just print out my balance onto the screen. I could just use a log, but this is a bit fancier. Let's close this. Don't know what that little notification was, there's a bug that needs fixing. Evidently there's something that needs fixing there. Let's just ignore it for now. As I said before, I need to include this enable web3 parameter, otherwise I'm not going to be able to connect to the blockchain at all. So now this has nothing to do with the door or the button, so if I click proceed, I should see my balance as 0. Oh, because it's probably because I'm in Ropsten, right? So if I jump over to mainnet, I should actually see the real balance that I'm holding. Because yeah, it's surely checking against the proper mana contract, which is a different contract in mainnet as it is in Ropsten. There's different like address for the contract. So if I click here, oops, it takes a second to fetch the information. There we go. That is how much mana I have, which is not a pretty number, but there are functions to express that as a prettier number. Okay, awesome. So another thing I wanted to, another thing I wanted to show off is how we can sign a message. So signing a message is a pretty useful thing when it comes to using the blockchain. So I'm just going to go over this quite at a high level. As you know, in my wallet I have a private key and a public key. My private key is at least supposed to be completely private, and no one should ever have access to it except me. And we can take a string and sign it, and we can encode it using my private key. And then that same encoded string can be decoded using my public key. So this is a great security measure that you might use in many different ways. For example, if you have a scene where you're recording high scores in a server, you might want to first have the player sign the message with a high score, and with that you can at least assure that the player was actually connected with his wallet while sending that request to record the high score. So that is a useful security measure for many scenarios. It's also a necessary security measure for many smart contracts that require that you send a string that has been signed using the private key. So I could do this same thing in the scene I'm playing around with. I could just add this part of the library which imports the Ethereum part of the module, and through that Ethereum module I can do the sign message. So you can just copy this chunk of code here. So let's get rid of this ugly thing I had done before. And I don't actually need to do this async execute task statement because I'm already in an async function. But let's do the UI.display announcement function so that you can see. Yeah. Signature. Great. So I'm sending the message MSG, this is a top secret message, and through this function I'm gonna encode it using my private key. And that's what's gonna happen whenever I click on our button here. Proceed. Now this will require that I sign the message using MetaMask. But this, of course, is not a blockchain transaction. This is not going to have a gas price because this is happening entirely in my machine. MetaMask is fetching the private key that is stored inside MetaMask in order to encode this message. And there we have our encoded message. Great. Trust me, it's working. Okay, so this library also exposes some other functions that are more can be used in a more wide variety of scenarios. For example, I was just showing you how you can use stuff with mana, but you can actually use any currency that adheres to the ERC20 standard. If I instead add this chunk of code here, I can now use anything in the currency section of my library. And let's erase this stuff, and let's uncomment what I had here. And so now I can do currency.send, and the currency.send function is just like the mana.send, except that I actually have to specify what contract I want to send. So what kind of currency I want to send. Whilst the mana one had mana by default, here we're able to set any other currency. So, for example, here I have the DAI, the address for the DAI currency. I can set that, and yeah, like with this, I could make this door be payable in DAI instead of mana. Maybe if I want to, make sure that the price is stable in spite of any fluctuations. So we can actually do the same or something quite similar when it comes to NFTs. I can require the player to send an NFT to a given address, and if I want to do that, the function Nft Transfer is actually quite similar. I just need to specify what kind of token to send and how and what specific token to send. For example, I could have a scene that requires that you sacrifice a wearable item whenever you want to enter a scene. And that could definitely be done with just a little bit more code than what I have right here. Another great thing about this library is that we are exposing a whole set of different contracts that are owned by the central end, so you don't have to go and look those up. So if you check, for example, in some of these examples here, instead of so here, for example, instead of having to look up the mana token contract, I can just do mainnet.mana token. And yeah, all I have to do is import this mainnet list here. And once I have that, I have access to all of these, which are all of the smart contracts that are related to the central end in one way or another. We have stuff for land, stuff for all of the different wearable connections. And so yeah, it's quite practical if we want to do anything that interacts with any of these. And I can also fetch the Robston equivalent of these same contracts. If I also import the Robston object here, you can instead do Robston and fetch the Robston contract for a bunch of different things. Great. So let's move on to another example that we have here in the awesome repository. Let's check out the Wearables Scanner. So what this scene does is it has this scanner thing that checks what wearables the player is currently using, and depending on if the player is wearing a valid wearable, the door would open. It actually reuses part of the code that we just saw in the button scene when it comes to opening the door. So if I go here, let's just show it in action. Oh, of course, important. And enable Web3. You're gonna see that a lot of times when the scene doesn't work, that's like the #1 thing you gotta debug. Make sure you add it and enable Web3 to the URL. Okay, so here is my little camera thingy, and when I walk near it, it scans me. It checks my wearables, and it checks to see if any of the wearables are eyewear. So as I am in preview, actually, if I look at myself, I am not wearing any eyewear. I'm just one of the default avatars, but it's actually checking out the information for my user in one of the in one of the servers for the central end, and there it has stored that my user is currently wearing shades. So if it wasn't, then that wouldn't have worked. So let's take a little look at the code here. So in fact, the code here could be a lot simpler. Again, the scene has things into little compartmentalized things. The door is its own object, and the scanner is its own object too. And if I go into the scanner, you'll see that it just controls the animations and the trigger area that makes it trigger when you walk near it. What really matters is here, this check wearable category function. And here what I'm actually doing is I'm using this library to get the full list of wearables that exist in the central end. Then I am actually, if I look in the console, I'm gonna see that this stuff gets logged. So there's a bit of noise here, but if I find the right stuff, here we go. So there's two arrays that are being fetched. One is it includes all of the existing wearables in the central end arranged by collection. So each one of these is a collection, and if I open one of these, for example, the Halloween 2019 collection, see that there's an entry for each one of the wearables, and there's plenty of information for each one of them. You can fetch the name, the proper name, the description, the long name, which is used internally. This actually is quite important. This is often what we're going to use when querying stuff. And also, more importantly here, the category. So right now, I am going through through this list and checking all of the ones that belong to the eyewear category. And on the other hand, I am also using another function from this very same library to obtain all of the wearables that the player is currently wearing, which are these. And these are the wearables I have on in the central end, not here in the preview. You can see I have the Thug Life shades, which belong to the eyewear category. So yeah, this function, first of all, fetches these two arrays, the full list of wearables and the wearables I'm using, and then it goes over both lists, comparing stuff and looking to match something that belongs to the eyewear category. We can actually do this in a much simpler way using our library here. If we wanted to specifically check if the player is using the Thug Life wearables, we could rely entirely on a function that is here, that was added quite recently. Actually, let me do one thing. Let's comment all this out, and let's check out the README because I can't remember the exact syntax for this. But we have a function that checks if a wearable is being worn by a player, which is this one, item inventory. Yes. So actually, let's rename this too. Yeah. So avatar dot item in inventory, and we gotta pass it the wearable name, the full wearable name, which is in this case this, and this flag checks if the item is currently equipped on the player or not. So for example, if I also own a fox mask, but I'm not wearing it, if this is set to true, then I won't be able to be let inside. But if I set this to false, then it doesn't matter if I have it on or off. It just matters that I own it and have it somewhere in my account. So if I just did this, sorry, I should be this scene should have the very same functionality that it used to have with all of this. Right now I'm not checking for the category where eyewear, I'm checking for one specific item of the eyewear category. So it's not exactly the same, but if you want to do that, that is quite handy. There's also a function that lets you check the same for a list of several different wearables in the same way. So if I wanted to, I could pass it a list of maybe 4 or 5 wearables that I consider to be, you know, the exclusive, you know, VIP club kind of wearables to use. So awesome, great. Since my character in the central end, not in this preview, is wearing the Thug Life shades, I was let in by this function. Cool. So let's dive into one final example, which is a little marketplace example that I built that is also, it could still use a little bit of polishing, but it's good enough to check some things out. So in this scene, what we're doing is we're showing several different wearables on display, and whenever you click on one of these wearables, we're actually using the Marketplace API from this is outside this library, but you can check out the example scene to see how we're doing it. And we're fetching several bits of information, and we're displaying them, and again, and enable Web3. I need to have that on. And now, thanks to this, I can check out any of these wearable items, and it will find the cheapest one on sale on the marketplace right now, and it will tell me the price. It will check if I have given authorization to the marketplace to use mana on my behalf. If not, it will take care of it, and I can click on this and buy it. So the function in the marketplace section of this library is actually doing 2 things. First is checking if you own, if you have, rather, if the player who has clicked has permissions for letting the marketplace operate mana on their behalf. And if it does, then it goes straight into the transaction and into buying the item. So this is all it really takes. Just gotta pass it the contract for the item that you want to purchase, the item name for the contract you want to purchase, and the price in mana that you'd be paying for the item. And with that, the transaction just gets carried out. So if I go to the marketplace, I can actually see that that I already do have this authorization marked in my marketplace. So then it's all right to let the marketplace contract operate mana on my behalf. But if a new player that hasn't enabled that on the marketplace walks in and tries to purchase something using this function from the crypto utils library, then the very same library is gonna first of all ask for a new transaction that will enable this checkbox here, and it will wait for that to be completed on the blockchain, and only then it will raise a second transaction to let the player do the actual purchase of the item in the scene. So that's quite handy. You don't need to worry about handling different scenarios in case the player has already given that permission or not. The same library also allows you to even put stuff on sale or cancel putting stuff on sale while you are inside a scene, which is probably a bit of a corner case, but we were already at it, so why not adding it? You can also query all of the different authorizations that the player has for using the marketplace. You could also do these very same kind of checkings and mark things to be authorized by other contracts other than that of the marketplace. So you could theoretically, for example, use the contract for OpenSea and give OpenSea permissions through a scene and do stuff with that. So the last thing I want to show you is how you can actually use any smart contract using this library. So all you really have to do is call the getContract function, and well, actually there are 3 getContract variations. One of them is for currencies, one of them is for NFTs, another one is for any contract at all. The benefit of using the one on currencies or on NFTs is that once you have created the contract, it will automatically expose all of the functions that are common to any ERC721 or ERC20 token. So that makes it a bit easier to use, because once you have created this this contract object, you can call the functions, and if you're using, for example, Visual Studio Code like I am, you will see the autocomplete options straight up there, which will make development simpler. But if you're using some other kind of contract that isn't either an ERC20 or ERC721, you can also use the getContract function that is inside the cryptoutils/utils/contract section of the library, and through that you can actually call any function on any contract you want. This particular getContract actually requires that you send it 2 things. One is the address of the smart contract that you want to deal with, and the other is the ABI. So if you're already quite familiar with blockchain development, this will be something you're already quite acquainted with. But an ABI is basically say a manifest of all of the functions that are available in a contract, and you can obtain an ABI for any contract if you go to the Etherscan page of any one of these contracts. For example, if I go here to the Etherscan page of the land contract, I can find the ABI for this contract if I go into the contracts tab here, and the first thing I'll see is the actual source code for the contract. I don't need that. What I need to do is scroll a bit lower, and right here I'll find the ABI. So if I want to use the ABI in a scene, all I have to do is copy this same code, and I can create a new file. Let's call it abi.ts. I can write export default, and then I can paste the whole contents of the ABI right here. And with that, I can import the ABI as something that is recognizable by TypeScript and usable by this function. So I believe that that's all of the most important stuff I want to share with you guys. There is a couple of more functions in this library that I didn't want to get into just now, because they may be a bit more advanced and I don't want to confuse you, and also they may be completely still under construction. But nevertheless, what I did show you just now does work, apparently. Crossing fingers, it will also work for you. If not, please let us know. We're still fixing things around and fixing bugs with it. But yeah, I hope that with this you can really take your scenes to the next level and do things that take full advantage of the blockchain in exciting new ways. Right, thanks for being here, and happy coding.